Hello, welcome to the fourth installment of the Chapter 21 video collection. This video is going to cover drug per hour, and this begins on page 330 in your textbook. So this is very much like volume per hour, except instead of looking at the amount of medication, we're going to be looking at the strength, the amount of milligrams per hour. So this is the dosage amount of medication in milligrams that will be administered per hour of infusion. Again, it's like the volume per hour problems, only we're looking at the drug per hour, and we're still going to use the ratio and proportion, where we then cross multiply and solve for X. So let's look at a couple of example problems of that. We have example 1, drug per hour. This is example 21.16. We have 100 milligrams of medication is to be administered and 500 mLs of lactated ringers over 2 hours. How much drug will be administered per hour? So again, you're going to set up a ratio and proportion and then solve for the unknown. So they started on the left-hand side of the equal sign with what we know or what was given to us in our equation. So again, this time we're looking at the drug or the strength of medication administered per hour. So we don't need the 500 ml. That is why they have 100 milligrams over 2 hours. It's being administered over 2 hours. And that is said equal to X, because we're trying to find out how many milligrams are being administered per 1 hour. Some of us can look at this one and already see the answer, but if you cannot, then we would cross multiply. 2 times X becomes 2X. 100 times 1 becomes 100. That 2 is being multiplied by X, so we'll have to divide by 2 to isolate the X. What we do to one side of the equal sign, we must also do to the other side of the equal sign. So 100 divided by 2 equals 50, which gives you X equals 50. So with this particular scenario, the individual would receive 50 milligrams of medication for every 1 hour. So that was the first example for our drug per hour. Let's look at example 2117. In 2117, we have 600 milligrams of fluorouracil is to be administered by continuous infusion over 24 hours. How much drug will be administered per hour? Well, I have 600 milligrams. That's my starting. And I know it's being administered over 24 hours. So we need to find out how many milligrams. And again, I just like to put my milligrams to help me remember my unit of measure. If you're good at that, then you don't necessarily have to do that. That's something I do for myself. I'm a very visual woman. Over 1 hour, right? We're trying to find out how many milligrams per 1 hour. And then we're just going to cross multiply. 24 times X is 24X. 600 times 1 is 600. This 24 is being multiplied by the X. So we need to divide by 24 to isolate it so that we can get that X all by itself. What we did on one side of the equal sign, we must also do to the other side of the equal sign. And 600 divided by 24 equals 25 milligram per hour. I apologize, I say I went out of frame. 25 milligram per hour. We'll do one last final example, just because I feel like these are not as complicated as the other ones. So I'm going to look at example 21.20 on page 331. And there I have a scenario that says 5 million units of penicillin G aqueous are being delivered in 1 liter of D5W over 12 hours. So how much drug will be administered per hour? Well, let's look at what we're starting with. This one's not provided in milligrams. They're just simply asking how much drug is going to be administered. We're dealing with units in this particular example. And it says that we are starting with 5 million units. So 1. And it also tells me that that is being administered over 12 hours. So I'm looking for how many units are administered for every 1 hour. So that is how the equation should set up. And then we're going to cross multiply to solve for x. 12 times x equals 12x. 5 million times 1 is still 5 million. The x is being multiplied by 12. So to isolate it, we're going to have to divide by 12. That leaves me with x. What I did to one side of my equal sign, I must also do to my other side of my equal sign. And 5 million divided by 12 comes to 416,666.7 or 0.67 units. Either answer would be acceptable. I see the book went with 6.7. I just went ahead and rounded to my tenths. But that's units per hour. That's how many units would be administered to the individual per hour. So again, I hope this video has helped you out, but if you feel like you still might need a little assistance or there's something you're not 100% clear on, please, please, please reach out to me. So I hope this has helped you out, and we will meet again in the next video installment. Hope you have a great day. Bye-bye for now.